Hi there everyone, today we are going to be looking at quadratic inequalities. Okay, so quadratic inequalities, relatively straightforward kind of concept in terms of what we need to do. It's a little bit like solving a normal quadratic equation. Alright, so if you've not done solving quadratic equations, I suggest you do that one first. So have another look at a video or lesson in relation to that one. But of course I'm going to cover over an awful lot of it in this particular lesson anyway. So when we're solving quadratic inequalities, we treat it the same way to start with. All right, so let's have a look first of all. So it's suggesting here that we solve an equation which equals 0 and find the critical values. Well, that's the same thing you do when you're solving an equation. All right, you're trying to find the solutions of it. But once we've done that, we've got to try and determine what those means and how we apply inequalities, which is what the table is talking about. All right, and then decide from there, those tables, is which values lie within the inequality that we are looking at to see if it works. Okay, so let's go through an example. So here we've got a quadratic, x squared plus 5x plus 6, and this inequality here says when it is less than 0. All right, so what we're looking for is a set of values where your x values is less than 0. Okay, so let's start off by just kind of solving it as a normal quadratic to find what we call the critical values. All right, so this factorizes, fortunately, and often they do. So we've got x plus 3 and x plus 2 equals 0, and when we're looking at the values to solve a quadratic, we're looking at each of the brackets separately to determine, you know, what value of x makes this equal to 0. Well, if I look at each bracket separately, what value of x in this bracket equals 0? Well, it's got to be minus 3. And what value of x in this bracket makes equal 0? And it's got to be minus 2. So those two values I've just mentioned are my critical values. Okay, so that's the point. If I'm considering what a graph looks like in the x squared or quadratic graph, that they're the two values that it is likely that my graph crosses the y-axis. All right, so I'm trying to determine which part of my graph therefore is less than 0. Is it in between minus 3 and minus 2, or is it bigger than minus 2, or is it less than minus 3? All right, so I've got three specific regions that I'm considering. All right, so this is where the table comes into play, is we consider what those regions are. So we've either got anything less than minus 3, anything that's in between minus 3 and minus 2, or anything that's bigger than minus 2. All right, and the only way we can do this without kind of drawing a graph, and of course you can draw a graph to kind of represent it if you wish, then we can just basically put some numbers in and see. So if it's less than minus 3, so for example minus 4, what do I get? Well, I'm going to substitute minus 4 into this quadratic equation and see what I get. So minus 4 squared plus 5 times minus 4 plus 6. So wherever the x is, I put minus 4, and that gives me a positive answer, or it gives me 2. That is not less than 0. Okay, so therefore that is not a solution set that works. Okay, let's try the next one. So we're going to between minus 3 and minus 2. All right, so between minus 3 and minus 2, we're now going to put in minus 2.5. Right, that fits somewhere in between. So into the equation, minus 2.5 squared plus 5 lots of minus 2.5 plus 6. And again, I've mentioned it in previous lessons, but it's worth mentioning again, is the reason that's in a bracket is that if you are going to put it into a calculator, if you don't put that bracket there, then your calculator will make a mistake. It will just do 2.5 squared and put minus in front of it, but of course that's not what we want. We want to do minus 2.5, all of it, squared. All right, and so that is really important. You kind of get used to putting that into a bracket, especially on a calculator. Okay, that's going to give me minus a quarter. All right, well that is negative, that is less than 0, so that's good. All right, so that is a solution set that works. And of course we need to try the one on the right hand side, which is when x is bigger than minus 2. So let's pick 0, put that number in. So 0 squared plus 5 is also 0 plus 6 is going to be 6, which again is positive. So that is not less than 0, so it's not that. All right, so the only solution set that works is any values between minus 3 and minus 2. And you could really try all the other values to see if that is the case, but I can assure you it will be. All right, so that is going to be my solution. All right, let's just look at the second element of quadratic inequalities, or a second example. And I put it when it's less than 0. Well, of course, it could be when it's greater than or even equal to 0. All right, so slight change in inequality, but the method is very much the same. We are still looking to basically solve it as a normal quadratic. to find the critical values. And then from there, obviously find the different solution sets. All right, so that one it also factorizes. This time x plus 5, x minus 2. And if you're not quite sure how I factorized it, then please look at the lesson on factorizing quadratics. All right, but that's what we do. So the critical values are minus 5 and 2. All right, so minus 5 and 2 is opposite of those, isn't it? That you see in the brackets. And then, like before, we're going to table of values when we're going to consider anything less than minus 5, anything between minus 5 and 2, and anything bigger than 2. All right, or equal to, I should say, because we are talking about an inequality which is or equal to. Right, so picking a value which is less than minus 5, so let's go for minus 6. Put that number in, and that's going to give you a positive. Well, is that what I'm after? Anything bigger than or equal to 0? Yes, it is. So that works for me. What about something in between? Well, between minus 5 and 2, let's try 0. So 0 squared plus 3 lots of 0 minus 10 is negative. Well, does that fit my criteria? Is that less than, sorry, is x squared plus, is it bigger than 0? No, it's minus 10. So not that one. And then we try something which is bigger than 2. Well, let's try 3. Put that number in there and you've got 8. And again, is that x squared plus 3x minus 10 answer that I have bigger than 0? Yes, of course it is. All right, so I've got those two. So my solution set for this one is a little bit different from the first one in that you've got the 2. So it's either x is less than minus 5 or x is bigger than 2. All right, and that is my solutions. All right, it might be something you need practice on or something you can revisiting on. All right, so please visit maths-school.co.uk, get some practice done, and hopefully you can have embedded before the exam. All right, thanks for kind of listening.